Okay, so good morning, everyone. Welcome to our today's workshop session. So today's just before we talk about today's session, I just want to say our today's training session will be recorded. So if you miss anything, you can always go back and review our today's session. So you can find our recordings. If you go to our website in the training, you can see a workshop and archive workshop. So after the workshop, you will be moved to the archive, and you can find our workshop session, the LBRN-LONI Bootcamp, and the recordings will be here. So after the workshop, we will upload all the slides, all the files, and all the recordings. But we highly recommend you to follow our today's session instead of go back and review online recordings. Okay, so our today's session is scientific computing with Python. So I suppose everyone was here yesterday. So yesterday we talked about introduction to Python. So I believe Kathy showed everybody how to get the material, how to find workshop material yesterday, but I will show you again how to get training material. So if you first go to, like I said, go to the training and workshop tabs in hpc.lsu.edu website and go to the upcoming and find our workshops session. Right, and if you go down, you can see there's a Bootcamp repository. There's a link to that, and you click it. You will go to the workshop GitHub page. Okay, you can see there are several folders, day 1, day 2. So today is our day 2. So you go to day 2, and there are still several files, and you can open the scientific computing with python.ipynb file is a Jupyter Notebook file. And if you open it, so okay. So if you can open it, there's a link at the top, open in Colab. You click the link, you go to Colab, you'll open this file in Colab. So I think we already talked about it yesterday. So I think everybody can open this file in Colab, right? So anybody has any problems, open this file from GitHub to Colab. Yeah, if you have any like questions, you can type it in chat, and I will take a look at it like every now and then. I won't be able to like answer your questions right away, but after like each several sessions, like small sessions, I will check the chat message and ask you if you have any questions, and you can type in chat. Yeah, I'm not sure. Still, some users have the distorted. Says the audio is a problem. So let me see. So what about right now? Is it better? Right, the audio is audio better right now? Since some users said my audio is a problem. It's better. Okay, yeah. Great. Okay. Low volume. I don't know. There's no way. I mean, I got just max volume, I think. So I'm not sure if you. Let me see. It automatically adjusted. So you just.
I think you can go ahead. From here, it's loud and clear.
Okay. Yes. Just maybe it's some internet connections from different.
If you happen to miss any sections, just watch the recording since the recordings are available. And most of the time you can watch what's going on the screen. So yeah, because due to the difficult time, everything is online. So if there is anybody that are one or two persons connection issue, sound issue, sorry, we are not able to like look at everybody's screen and solve your problem, but the recording is available. So please do stay tuned.
Yeah, just okay. Yeah, just let me know like if you cannot open this Jupyter notebook file. I think everybody can do that because we already did it and we had a hands-on session like yesterday afternoon. So I think we fixed most of the problems. So okay, I will start today's session. I think so. For today's morning session, we will first review yesterday's Python session briefly, some of them, and then we will mainly talk about the Python module, NumPy, and we will just talk maybe just one example of SciPy. So then I'll show you several examples of using these NumPy modules. And at the end of the morning session, I'll give you the exercise about NumPy. And we will talk about exercise in the afternoon sessions like yesterday. So first, let's review what we talked about yesterday. We talked about what is Python. Python is a general purpose interpreted, interactive, object-oriented, and high-level programming language. And we talk about data type in Python, strings, list, tuples, dictionaries, right? And we talk about Python loops, for loop, while loop, and we talk about if statement, right? With a lot of examples. Right? So let's first check here two examples of Python loops. So here we have A equals to list range 5. So we talk about range and list function yesterday. So if we print A here, we get 0, 1, 2, 3, 4. So range starts from 0, but 5 is not included, right? And here there's a for loop for IDX in range length A. So we can use the function length to get the length of A. So A has 5 elements. So we are actually, this is actually range 5. So for each IDX in range 5, A IDX plus 5. So what does it mean? We use IDX as the index of the element of A. So we already know the result of range 5 is printed here. So IDX starts from 0. The index 0 of a list is the first element of A, right? So we add 5 to the first element of A. So we basically, in the for loop, so we basically add 5 to every element of A list. So, and then we print A. You can see we basically add 5 to every element. So this is a way of adding numbers to each element. And this is so not a very efficient way. And we will show you how to do it using NumPy. And why NumPy is faster. So we also talked about tuple yesterday. So tuple is immutable. So for today's session, we will use tuple to represent the shape of an array. So we will talk about later. Let's first check a few examples. Right. So for the first example, you can see we can put strings and numbers or even lists in a tuple. And we define a tuple like this. We can define a tuple with the parentheses and without, right? Here, right? Strings and numbers and without parentheses. And we can define a tuple, empty tuple like this without anything inside, right? And if we want to define a tuple with only one element, you you will need to add a comma here. And this is a version without parentheses. And we can also use index to access element in the tuple. Like this. Here's another example. So here's another example of we want to change the element in tuple, one of the element, and it returns an error because tuples are not immutable. Tuples are immutable, so you cannot change anything, change any element inside. So you can also use slicing. So everybody remembers what is slicing. We talked about yesterday, right? Slicing so means we want to get the second to the sixth element in the tuple. And if we add two tuples, you will not get the sum of them. You will merge these two tuples, right? So, and we can also use the del command, del command to delete what we created in Python. And if we print it, we'll return an error because we deleted it. Yeah, this is just a quick review. So do you have any questions? Anybody has any questions here for the review of yesterday's session? Okay, I didn't see anything in chat. So, okay, I'll move on. I'll move on. Difference between tuple and list? Yeah, yeah, a lot of common things like I talked about. You can see you can use index to access the elements. You can use slicing and the way of define a list and a tuple is kind of different. So for list, you always use square brackets, and list is mutable, so you can change. You can change the elements there. You can add elements there. You can remove elements there. But for tuples, you cannot. So there's an exception we talked about yesterday. Right? So yeah, it can be copied, but it cannot be changed. It cannot be changed. The element cannot be changed. You cannot delete elements or something like that. But there's an exception we talked about yesterday. When there's a list inside a tuple, when you define a list inside a tuple, then you can change the list, which means you change the tuple. But that's the exception. So well, it really depends. Like we also talk about this in yesterday's session. So it depends on how you define the copies, right? If you say assign A equals a tuple and B equals to A, then they're the same. But if you assign A equals a tuple, B equals a tuple, and they have the same values, they are two different tuples. Right? Yeah. If you do not still not clear about it, you can go back to and check our yesterday's session. So there's an example about it. I think Kathy had it. So any questions? Is it possible to convert tuples to lists? I have never done it, but there's a way. There's a way. Okay, yeah. Phone added something, so you can, if you have any questions between list and tuple, you can use that link. I think it might be helpful. So I'll move on. The screen is freeze. Okay.
If you want to convert tuple to list, it's very easy to do. just a list and parentheses, and inside the parentheses put the name of the tuple, and so that will be converted to list.
Okay, yeah, I'll move on. So in today's session, we'll spend probably most of the time talking about NumPy. So NumPy is a fundamental package for scientific computing in Python. So it's mainly used for multi-dimensional array objects, provides a lot of basic routines for manipulating arrays and matrices. So what is a NumPy array? So a NumPy array is a grid of values. All of the NumPy array elements have the same type. A NumPy array starts its index from 0. So let's first check some simple examples of NumPy arrays. So if you want to use NumPy, the very first thing is to import NumPy. So here we import NumPy as MP. So when we want to use NumPy, we do not need to type NumPy because we import it as MP. So we just use MP, which is much easier. And here is how we define array, a NumPy array. So A equals to MP dot array from a list 1, 2, 3. It means we want to define a NumPy array with element 1, 2, 3. And we can also define array from a tuple. B equals to MP dot array 4, 5, 6. So we define array B from a tuple with element 4, 5, 6. Right? So if we print them, you can see the result. They look exactly the same as the list. Right? So let's do some calculations. So if we try A plus 1 and B times 2, what is going to be the result? So in yesterday's session, we talked about list, right? So if B is a list and we run B times 2, what's going to happen? We will get a list with 6 elements, right? And the elements will be 4, 5, 6, 4, 5, 6. Because you will merge the elements of B. Right here, B is a NumPy array. Our NumPy array supports vectorized operations, like element by element operations. So here, if we print the result, we can see actually A plus 1 brings the result 2, 3, 4, right? We actually add 1 to every element of A, while B times 2 brings A 10, 12, and we get times 2 to every element of B here. Right? So if we do A plus 1, right, the result will be a NumPy array with 3 elements instead of 6. So it will do element by element operations. So we will do the first element of A, add the first element of B, and the second element of A plus the second element of B, and so on. So we get 5, 7, 9 here. And the same thing for A times B, right? We get 1 times 4, 2 times 5, 3 times 6. And same thing for A to the power of B, right? Any questions for this section? For the NumPy array, very simple usage for NumPy array. So, okay, so no questions. Then you can also use for NumPy arrays. You can also use the index, and you can change the element of a NumPy array like this. So here we want to change. We use indexing. So index 0 means the first element. Right? So NumPy array's index starts from 0, the same as list. Right? And we want to change it to 11. So what is A? A is 1, 2, 3. Okay. So if we print the result, the first element will be changed to 11 instead of 1. Right? Right. Okay. And like lists and the strings. There are a lot of attributes for NumPy arrays. We can use a.fill to set all elements in the array with the same value. So here you can see a.fill 0, which means we want to set every element in A as 0, right? And for slicing here, this slicing means all the elements. So we want to change all the elements in A to 1, and we print it. You can see that we change it to 1. And we can also use dtype to show the data type of elements in NumPy array. So all the elements A are integer, so it prints int 64. So int 64, okay? So which means it's they're integer numbers and takes 64 bits. Okay? And if we print the type of A, it will show it's a NumPy n-dimensional array. Right? It's like very straightforward. Here, so okay, so we know the data type A is integer, right? And if you want to say change one of the elements to a floating point number, so like 10.6, so what can happen? Well, you can see the result will be 10 and they'll be truncated towards 0. So the same thing for fill, okay? So you can see we want to fill it with negative 3.7, right? If you print it, it will be all changed to negative 3. So I think this is how we several examples of how to use NumPy arrays. So any questions? Let me check the chat. Real quick. Is there a fill function for list? I'm not sure if there's a fill attribute for list, but I mean, since you can change everything in list, so it won't be very complicated, I think, to change anything in list. But for list, it's not like NumPy arrays, so you have to probably do a loop for all the index, all the elements in list. But in NumPy arrays, is there a way to not truncate decimals with NumPy? Yes, we will talk about later, right? How we assign the floats in there. Yes. Yes. Why the truncated again? Yes, because the data type is integer. So just remember, okay. So all of the elements in NumPy array will have the same data type. So if they're integer, so they'll be integer. So I will show you like other ways of change the data type in NumPy arrays and other functions. We will talk about it today. Yeah, we will talk about it today. Okay. Yes, it is. I'm not sure what you mean. Is it declared by what was used at first occurrence? So you mean what data type is it?
Yes, I can. Yes, when you first declare a NumPy array, the data type is determined. So by default, I believe it is either a float or integer. But later on, you can convert that into a different data type. Does that answer your question? No, you cannot use chars. NumPy arrays for numerical values, so they're either float or integer.
I believe it can be used.
Yeah, when you define a NumPy array, you can define a data type as a D type.
Yeah, we will cover everything.
Yeah, we'll cover that later. But please don't try to use the chars with NumPy arrays. NumPy is for numerical arrays.
Yeah, for these operations, like for today's session, there's no string involved. Maybe like Boolean values involving NumPy arrays. For today's training session, there's no strings involved because like we cannot do.
Basically, the NumPy is for numerical simulation, so char is not for numerical simulation. You cannot do that.
Yeah, we normally don't use strings for that. So, yeah. Okay. I think most of the questions can be solved in today's session. So I'll keep moving. I think so. Here, like creating, you can see the next session is creating floating value arrays. So when we create a NumPy array, so from a list, if one of the elements is a floating point number, so the other elements will be changed to float. Okay. So and the data type of the NumPy array will be float. So this is an example. You can see if you print it, the D type will be float 64. And if you notice that, like you can see the results, there's a decimal point after 1, decimal point after 2, and the data type will be float. So which means all of the elements in this array will be float. Okay. And there's another way to create floating values array. So you can see here when we define array, we can specify D type here, right? Here you can see inside the mp.array parentheses. So if we print it, right, you can see they're all float, right? And another way is use .as type float, right, outside of the parentheses. And here you can see, okay, we get the same results, right? They're all floats, right? So I think this solves some of the problems, and then we will talk about NumPy array properties. Okay, so let's check some attributes of NumPy arrays. So first we create an array, and then a dot shape. Okay, A is a NumPy array we just defined. So a dot shape will return the shape of this array. Okay, by using a tuple. Right. So you can see A is a one-dimensional NumPy array with 4 elements. So you can see it prints 4, but it is only one-dimensional array, so there's only one dimension here. And we can also use A.size, right, to print the number of elements in A. So A has 4 elements. And A.n-dimensional will print the dimension of A here. Right. So any questions for these? I think very simple examples here. My screen is always frozen, I don't know why.
So just add one comment regarding the NumPy array with char. If you do search the web user, there was a NumPy char array, and for backward compatibility with num array, which is not recommended starting from NumPy 1.4. So I personally never used the NumPy char array as the type of numerical simulation. It exists, but it's not actually a type really aimed for numerical simulation.
Okay, so I didn't see any questions in chat. So yeah, they're float 32 and float 16, I think. Yeah, and next we're going to talk about NumPy array creation functions. So basically how we define a NumPy array in different ways. Okay. So first we will talk about np.arrange. So our np.arrange is pretty much the same, very similar as a range function. We define start, stop, and step. So if we only give one number in the np.range function, so we can, the number will be the stop. So if we print it, you can see we get 0, 1, 2, 3. So the step by default is 1, and you will start from 0 by default. The same as range. And if we specify two numbers, 0 and 4, right, there will be 0 will be the start, 4 will be the stop. Okay, right, we get the same result. And also for arrange, we can also use d type here inside to change the data type here. And we can for arrange, we can also use flows for start, stop, and step. Here is an example, and we can use NumPy universal functions like np.pi, which has a value of pi for the arrange. Right. So next, we'll talk about the second method is there's some useful initial value creations. So basically some functions in NumPy which helps you create NumPy arrays. So first we use np.once, right, to create an array, and it will create an array filled with ones. So we'll need to provide the shape of the array using a tuple like this. Like here, the tuple has element 2 and 3, so we will we'll create an array with a 2 by 3 array. So if you print it, you can see it's a 2D array, right, with 2 rows and 3 columns, and the data type will be float, right? So which means by default, these functions, right, the data type of these functions will be float. So and then we can use zeros, like very np.zeros, similar as np.ones. Basically, it creates a NumPy array filled with zeros, right? And we will also use a tuple to specify the shape. And np.identity and np.I will create a identity array. So the identity array is a square array with ones on the main diagonal. So let's print it so you can see ones on the main diagonal, others are 0. And i's, np.i's will do the same thing, right? And here you can see we change the data type to integer. So you can see all of them becomes integer, and the data type is int64. So and we can use np.empty to create a array with arbitrary numbers. Okay. So you can see we printed, there's just some arbitrary numbers without initialization with specific numbers like ones and zeros. Yes, float is the default for these functions. So like I said, by default, so for these functions, like you can see ones, zeros, identity, empty. So by default, right, it's a float 64, but you can always change it. So you can see you can put a d type here. Right? So let's change it to integer. So any questions for these examples? Okay, I didn't see any, so I'll keep moving. So next we will talk about NumPy lane space and log space. So 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 link space and log space can help us get evenly spaced number on a specific interval on a or use a log space to get a specific log scale. So for NumPy link space, we define start and stop, and also we can define how many numbers of element is how many numbers of element we want to generate. Okay, by default is 50, so you can define it by yourself. And endpoint is also optional. So if the endpoint is true, then the stop will be included, otherwise it will be not. So endpoint by default is true, right? And red step is also optional, which means return step, right? So if it's false, well, won't return the step size because it returns specific interval. So for every number, the interval will be the same. So if it's true, it will return one number, which is the step. And D type is none, so by default, it won't specify D type, but you can specify yourself. And let's see example 015. Which means our start is 0, stop is 1, and we want 5 numbers. You can see the result here. And log space. So for log space, it's pretty similar. So a little bit different is for the base. So by default, the base is 10. So you can always change the base by yourself. And for log space, the sequence starts at base to the power of start and ends with base to the power of stop. Okay, let's see an example here. We have a MP dot log space 01, and we want 5 numbers, right? We'll print it. We can see the first element is 1, the last element is 10. So let's check it one by one. So for the first element, how we get it? So we get it from 10 to the power of 0, which is the base to the power of start, right? So what is the second element? Second element is 10 to the power of 0.25, right? And the third element is 10 to the power of 0.5, right? And the last element will be 10 to the power of 1, which is the base to the power of stop. Right here, another example, we change the base to 2, and you can see the result. So there's a question, why is log space D type default none? Oh, well, by default, I mean, so here default none is default, the D type will not be set, right? The default, the D type will not be set, but by default, it will bring float. Even though they're just say if they're all integers. So let me do a test for you can see for link space. If you do 0, 4, start from 0 and it's 4, and we want 5 numbers, so they're basically integers. Well, if you do, you can see they're all floats. Right? So by default, there will be floats. Right? So the D type none, which means the D type is not set by default, but you will return float by default. Like it's optional, right? Even the number of elements, the endpoint, the base, the D type is they're optional. Right? You just need to specify start and stop. But by default, you will have some values, right? Just like numbers by default will be 50. Uh,
I want to add something. The default equal none. That means the NumPy does not predetermine the data type.
yeah. Yes.
So it will be very slow. For every input, it will try to determine the type of it.
Mm-hmm.
But if you specify default equal float, then NumPy will know, okay, this is a float. Everything comes from this function, it will be a float. So there will be no overhead for determining its data type. So it'll be fast.
Yeah. Okay. No questions, no questions. So, okay, let's move on. So, next we'll talk about how to load arrays or how to load data from a file. So here we have a file, data.txt, right? So we did the same thing yesterday. The first thing is download the file. Okay. The command will check if the file exists. If not, then it will download the file. And then we show the content of the file. So you can see here, we have a file like this, a lot of lines and a lot of comments. Like we know like the first like 17 lines are just basically descriptions or comments for this file. So for these contents, we don't want it. What we want is something here, right? We have 4 columns and we have 4 columns of data here. So we want to get the data from this file and remove all the descriptions. So for NumPy, we can use the function np.load.txt to load data from files. So first, we will specify the file name, and here skip rows 16, which means we will skip the first 15 rows or the first 16 lines, right? And then here use columns, so which means we will use so this is basically index of columns 0, 1, 2, which means we will use the first 3 columns. Right? So okay, the type is none and comments. So we will use the pound sign as a comment, which means we will ignore the lines starts with pound sign. Okay, so after we do that, and then we print A, we can see NumPy will print the array for us, right? It's a 2D array with all the information we need, and it removes all the descriptions and the comments. Okay? Very fast and very convenient. Normally, you either do it manually or just write some loops to remove those things. But here, using NumPy is faster, and we can also use another function, gen from txt, generate from txt. So here you can see very similar. We have the file name and we skip those, but we don't specify the comments. Right? So we don't specify we using pound sign as comments, but this function will figure out by itself. And if you run it, we can see it gets all the information we need, like 4 columns, right? And numbers and strings, right? Very fast and convenient if you use NumPy for that. So any questions? Okay, type of A, I think is array. So you can, so A is array. So or you can do or you mean it's float, right? And A is array. If you do you can change the type here. You can change the type. Right? You can see you can specify the type here. Well, it's very different because you can see. Let's see. Let's check. In the array, yeah, they're basically different. Well, the gen from the encoding can be changed. So for gen from TXT, so I think gen from TXT is a little bit more complicated than load.txt. If you check the documentation file, there are tons of options. Right? I did not. It's array. It basically created. It says MP dot n dimensional array, but if you go to the documentation of gen from TXT, it's very complicated. Like there are like over 10 options there, and there's a specific logic behind it. So for gen from TXT, these are basically two simple examples from a simple file. But if you want more like specific, more complicated files, then you probably need to go through the gen from TXT documentation and see what it does. But it's way more complicated than what I show here. So like, I mean, if you have a simple file or you want to extract data, but you don't need to like use loops, right? You can use those NumPy functions to get the array here directly from the file. So instead of writing a loop which takes a lot of time, or something very complicated to remove the comments, to remove the descriptions, you just need to use this one function. So very simple. Yeah. And I think load txt is I think it has less options. For the gen from TXT, it has more options there. So if you go to their documentation, you will see. So this is what I want to show here. So if you have any questions, we can probably spend more time for the hands-on sessions this afternoon, I think. Okay. Yes, they're non-parents. We just printed. So. Okay. Next, we will talk about change the dimension of the arrays. Okay. So the first, we will define array, 1D array, and we will print the shape. And we can change the shape of the array by here, like a dot shape, and specify a new value to a dot shape. So initially A is a 1D array, and we want to change it to 2x3. So we specify a tuple with element 2 and 3 for A. So we can see it has been changed to it will return a 2x3 array like this. And we can also use a dot reshape, right? And specify the new shape that we want. I print it, well, A will become a 3x2 array, right? And here, so you can specify just only one of the dimensions of the new shape. So you cannot leave both of them as -1. -1 means you want NumPy to determine by itself. You cannot leave both of them -1. It will give you an error. But you must define one of them. It's okay to just define one of them and then NumPy will figure it out. So A has 6 elements. So the one of the dimension is 2, then the other one will be 3. So you get a 2 by 3. And here the same, you will get a 3 by 2. Right? And then after we shape the array, or say we get a 2D array, we want to change it to a 1D array. So see, we have a like 3 by 4 array here, and then we want to convert it to a 1D array. So we can use a.flatten, right here. Yeah, it will be changed to a 1D array here. So let's see. Let's talk a little bit. Any questions? Any questions for the shaper reshapers? No questions? No questions so far? Okay. So as we talk about at the beginning, so we said NumPy is pretty fast, and we do not need to use loops for those kind of calculations. So here is a example of the speed of using a loop, a Python loop, and a NumPy array. So here you can see we use a time it expression to time the execution of a specific expression. So here we can see the first expression we want to time is a Python for loop here. Okay. The second expression we want to time is a plus 5. Well, a is a NumPy array, and you can see how many elements a has. So you can see it has 100,000 elements here. And then finally we compare the speed. Okay, let's first run the Python loop and see how long it takes. Okay, and then we run the NumPy array and see how fast the calculation takes. Okay, and then we see, okay, you can see by using NumPy arrays, a NumPy array is like more than 40 times faster than just using a Python loop. And so which means using NumPy array is more efficient, especially for large amount of data. So here we only have 100,000, like in practical, you may have like way more than this number. So using NumPy array will be faster and more efficient. So here we talk a little bit about why NumPy is faster. So since every element in NumPy has the same data type, so it avoids type check overhead. So you know Python is a dynamic type. So before it do the operations or it use a variable, it will check the data type. So for NumPy, it won't be that complicated. And then NumPy array supports vectorized operations, and then many of the built-in functions implemented in compiled C code for NumPy, so it will be faster. So I think it's about an hour. So I think we should have like probably 10 minutes break. And after the break, we will talk about 4 tools or 4 methods of NumPy, and then we can use these tools of these methods to avoid using Python loops, okay, to improve the efficiency of the code. Okay. So, and then we will show you a few examples of using NumPy tools. Okay, so I think let's have a break. I will pause the recording. So let's continue. So before the break, we talk about we will introduce 4 tools and 4 methods in NumPy. Right? So the first one will be the universal functions. Right? Here you can see the examples of universal functions. Like we have already talked about all of them, like np.py, np.sign, and those arithmetic operations. So here are a few more examples, right? np.py here, and we have x times 2, right? And we have a sine function here, and we can plot it by using matplotlib. I think very simple, right? So I think everybody has already have an idea about the universal functions, right? So next we can talk about aggregation functions. So what is aggregation functions? Right? So the aggregation functions summarize the values in the array, like minimum element of the array, the maximum of the array, and the summation and the mean, right? So before we talk about examples of aggregation functions, let's see the definition of access of NumPy arrays. Okay, so here you can see a box. For NumPy array, the axis 0, which is the first axis, like the index is from 0. Right? Axis 0 is a vertical one here. And axis 1 is the second axis, runs horizontally. And it across all the columns, right? And axis 2 is the third axis, is the third direction, right? So, okay, this is the definition of the axis. So let's see some examples of aggregation functions. Here we define array, and then a dot sum, right? We know a dot sum, it basically just add all the elements from A, right? So it returns one single number, which is 15. And another way of using sum is np.sum A. It's basically they do the same thing, right? So here, so you can see the third example. Here we use np.sum A, and we added axis here. So axis 0, right, which is axis 0, is the first axis, vertical direction, right? So there's something in general. Wait, I can't open chat. Oh, why? Okay. Okay. We will talk about later. Right. So the recordings we'll talk about later. Okay. So for the axis 0, so we already seen it's the vertical direction. So what does it do, right? It basically will sum the elements of A along the axis we specify. So axis 0 is the vertical direction. So we can see A is here and vertical direction, right? So we will add 0, 3, 1, 4, and 2, 5, right? And you will return a 1D array with those results. And here, same thing, axis 1, right? Axis 1 is the horizontal direction, right? So across all the columns. So basically, they're just sum of the rows. So you can see 0 plus 1 plus 2, 3 plus 5 plus 4, right? So we get the results 3 and 12. So here, axis -1. So just like the indexing, I'm not sure if we talked about yesterday. So for index, the -1 is the index of the last element, right? And for axis is the same, which means it's the last axis. But how many axes does A have? It has 2 axes, right? 0 and 1. So last axis is 1. So you will return the same result as x is 1. Okay, so here, np.prod basically returns the production, right? And we can also specify the axis for np for the production. Same thing for axis 0 will be the production of all the elements along axis 0. Okay, we'll get 0, 4, 10. Let's go back and check. 0 times 3, 1 times 4, 2 times 5. Right? It will be 0, 4, 10. And axis 1, 0 and 60, right? It will be 0 times 1 times 2 will be 0. 3 times 4 times 5 will be 60. Right? Right. So here, another example. We use np.setPrintOptions to set the precision of the result. Okay. So basically, we set the number of digits of precision for a floating point number. Okay. So, and here np.random.random create arrays with random flows from 0 to 1. Okay, let's see what is the result. Okay, the result is going to be like this. Right? We get random flows from 0 to 1, right? With 4 digits after the decimal point, right? And here, a.mean, right, basically returns the mean of the elements along axis 0, along axis 1, right? And if we only if we do not specify any axis, we will return the mean of all the elements in A. And then this is another way, same as a.mean, np.mean, right? And if you want to add weight to the mean, to the average, you have to use np.average, right? In np.average, you can specify the weight. Right? If you do not weight, what is weight? Like here's a expression of how to use weighting average. And then we apply those weights along axis 1. We get a result like this. And you can also use, you can have functions for standard deviation, for variance, right? And for, if you want to find a minimum number in A, you can use a.minimum, and maximum the same. And also, here is a function a.argmin. So it returns the index of minimum value along a certain axis. So here you can see this example. We use a.argmin and we specify axis 0, right? So let's see what is A, most recent. A is this, right? A is a 2x3 array. So along axis 0, right? So you can see the axis 0 is a vertical direction. So you can see for the first 2 elements, which is smaller, the second one is smaller, right? For the second one, for the second column, the first element is small, right? And for the third column, the second one is smaller. So we will get, so for index, the second element is 1, the first element is 0, so we'll get 1, 0, 1. Right? So if we print the result, right, we can get 1, 0, 1, right? And argmax, yeah, basically will print the index of the maximum number along the axis 1. So let's see A. What is A? So it will be different. Well, since it's a random number, so for everybody, if you run it, the number will be different. So the results might be different, but the rule is the same, right? So if we see the argmax, so along axis 1 is the horizontal axis. So let's take a look at the rows. So here, which one is larger? For the first row, the first number is larger. For the second row, the first one is larger. Yes, also the first one. So we will get 0, 0, right, as the indices. Right? So here, if we use the argmax or argmean, right, without specifying the axis, it will find the index of the largest number based on the flattened. So basically, well, we talk about the flatten command there, right? So if you have a 2x3 array, if you use flatten, will be array. So well, based on that, and you can see we will print only one number, which is the index of the minimum or the largest element in the flattened array. Let me see the chat. Yeah, random twice is because mp.random is a function in NumPy, right? So and mp.random, and random is I think is an attribute, a function of mp.random, right? So you have to use mp.random.random twice. Right? It's not like using it twice, but mp.random is a function itself, and it has an attribute of random. So you use mp.random.random. Is that clear? Yeah. Okay. So any questions? Any questions for aggregation functions? I think most of them just like very straightforward. Like some like mean, you basically just use it like directly. So okay, if there's no question, then I'll move on. So next we will talk about array broadcasting. Okay, one more. Yeah, the index -1. I think yeah, I should have talked about it, but I will mention later in the slicing section. So the axis -1, as it's like the same as the index. So we have so for indexing we talked about yesterday, right? The index starts from 0. So if we have a array with 3 elements, right? So the index of their elements will be 0, 1, 2, right? 0, 1, 2. And then there's a reverse index, right? So the reverse index and so we call it like the negative index. So for the negative index, -1 means the last element, right? So if you have an array with 3 elements, their index for negative index will be -3, -2, and -1, right? And same thing for index, like I mentioned for index, for axis, the index of axis starts from 0, right? The first axis is 0. Yes, the -1 means the last axis. So just like the index, -1, the axis -1 from means if yeah, it's no longer the same as it's not. It's axis 3. Yes, correct. Yes, means the last one, no matter what the last one is. In this case, the last one is 1, right? Yes. In this case, the last axis is an axis 1. So you will print results like this, but if you change the array to a different dimension, then it will be different. Yes. Any more questions? Okay. I didn't see any more questions here. Okay, so next we'll talk about array broadcasting. So like for previous examples, we showed you like A plus B, something like that, and for 2 arrays, and we only use arrays with the same size and same dimensions, right? both of one array and they have like 2 or 3 elements the same. And like, what if their size and dimensions are different? What will NumPy do if we want to add 2 arrays with different size and dimensions, right? So in this case, NumPy will apply a broadcasting rule. So let's see what is the broadcasting rule. So the broadcasting rule is in order to broadcast, the size of the trailing axis for both X arrays in an operation must either be the same size or one of them must be 1. Okay? It's not like very straightforward. So let's talk about these we have 4 examples, and after these examples, I think you guys can understand what is the broadcasting rule. So let's take a look at the first example. Okay. So for the first example, we have an array with 1 row and 3 columns here, and we have a number here. So for a single number, it only has 1 row and 1 column. Okay. So let's first compare their number of columns, right? So for the first array, it has 3 columns, and for the second one, it only has 1. So the number of columns of them are different, but one of them is 1, right? So let me finish these examples, okay? So one of them is 1, so it's okay to broadcast. And let's see what is the number of rows. So the first array number of rows is 1, the second one is 1, so they're the same. So they can be broadcasted, right? So since they have the same number of rows, right? For columns, for 5, it will be expanded to like 3 columns, and 5 will be copied twice. And these are the arrays that used for this operation for addition. So we finally get array 5, 6, 7, right? So then let's see the second result, the second example. So here for the second example, we have a 3 by 3 array, and we have a 1D array with 3 elements. So first, let's compare the number of columns, right? So they both have 3 columns, right? So the same value. And for rows, the first array has 3 rows, the second array has only 1 row. They're different, but one of them is 1, right? The second array has 1 row, so they can be broadcasted. So here you can see the rows of the array will be copied twice to 3, right here. And these are the arrays that used for this operation. And finally, we get an array like this. Right. Okay. For the third example, we have an array with 3 rows, 1 column, and 1 row, 3 columns. Right. So both of their number of rows and number of columns are different, but one of them is 0. So for the first array, the column is 0. For the second array, the row is 0. So they can be broadcasted. So here you can see this is the way how it is broadcasted. Because the second array, it has 3 columns, so the columns of the first array will be expanded to 3. And for the second column, for the second array, since the first array has 3 rows, the row of the second array will be expanded to 3. So we basically use these 2 arrays for the operation. So finally, we get an array like this. Let's see the fourth example. So for the fourth example, it won't work. So why? Let's compare. Let's do the same thing. Let's compare the number of rows and number of columns. So the first array, it has 3 rows, and the second array, it has 1 row, right? It's okay because one of them is 1. Well, for columns, right? The first array has 2 columns. The second one has 3. They're not equal, and none of them is 1. so they cannot be broadcasted. So you cannot add these two arrays together, right? So here are some examples. That basically these examples of code is exactly the same as what we talk about in these figures. So if you run this code of examples, you can see like we just talked about, right, here. And yeah, they're basically exactly the same as what we have in the image. So here is the last example we talk about, right? So we have a 3x2 array and we have a 1D array with 3 columns. We want to add them together, right? Python returns an error. So this is, right, very clear, could not be broadcast with shapes, right? You can see. So I think very straightforward. So any questions for these examples of broadcasting? I think any questions so far?
For the mismatch one, if the right one is 4 columns, can you copy the left one to make it 4 columns?
Which you can't.
No, you can't, because for columns they're not the same. So if the second one has 4 columns, then you can see 2 and 4, they are not equal, and none of them are 1. So they still cannot.
Thank you.
Yeah, they must be equal or 1. So even though, like, you see this is 2 and this is 4, and they cannot. Even like if you copy it once, right, 2 columns can be 4 columns, but they cannot be broadcasted.
Yeah, in the past few years, when we talk about the broadcasting, and especially for this mismatch example, many people think, is it possible to do like the least common multiple? And no, NumPy is not going to do that, and there's no way to do that. And that way will make the problem extremely complicated, and NumPy is not designing that way.
Yep. Yes. Any more questions? Okay, so I didn't see any questions so far. So okay, let's talk about slicing, masking, and fancy indexing, right? So first we will talk about slicing. Okay, so I think we talked about slicing yesterday, right? For a list, right? A list for a list. So here the rule is pretty much the same. So but here we can use lower and upper, and also we can specify the third number as step, right? So this is one thing, and the second thing probably we didn't mention yesterday is the negative indices. So we just talk about it, like, so here, for example, you have a array with 0, 1, 2, 3, 4, 5 elements, right? And they're negative in, so that's no, I mean, so five elements. So the indices of those 5 elements will be 0, 1, 2, 3, 4, right? Like we talked about yesterday. But for negative indices, they will be -5, -4 to -1, and -1 will be the last. It will be the indices of the last element in this array. Right? So so I was not planning to go through this one by one, but since we don't talk about it yesterday, so let's go through them one by one. So for the first, right, pretty much the same as what we talked about yesterday. So wait a sec. I didn't run the first one, so let me run the second one. Okay, so so basically the slicing, this slicing means we want the element, the second element to the fourth element, basically from 11 to 13, while the fourth element, the stop will not be included. So will be 11, 12, right? So here, the second example, 1 to -2. So let's see. Okay, 1 is the index for the second element. -2 is the element for the second to the last, right? So which means we have 0, 12, 13. Well, 13 is not included. So we have exactly the same results. Okay. And here we have -4 to 3. -4 is the second index, and 3 is the fourth, right? The second to the fourth, right? And fourth is not included. So again, we get the same result. And for this one, if we do not specify the start, then you will start from the beginning of A and then until the fourth element. So we get 3 elements here, right? And -2 basically means we start from the second element. If we go from the second element, start from the last one, start from the second to the last one, right? So we get 2 elements, and we don't specify the stop, so it will go all the way to the end of the array. So we get 13 and 14. Right here, the same thing as -2. We start from the second element. Right? Second element is what is 11 until the end of the array. So we get 4 elements here. Here the same thing, right? So here you can see we want the elements from the start to -1. -1 is the last one, right? But last one is not included, so we also get 4 elements here. This is an entire array, like straightforward. And here you can see we have 3 numbers, right? We have two column here. We don't specify the first number and second number, right? Which means we wanted to go all the way from the start to the end, but we specify the step here. Step here 2 means you will print every other element, right? You can see we get 10, 12, 14. So at 10, I skip 1 and print 12, skip 1, we print 14. So it's 10, 12, 14, right? And then here the same thing, right? We specify the start. It starts from the second element, right? Then we get 11 and 13. So I think very straightforward. Just 2 things. The first thing is the step. Second thing is the negative indices. So everything else is exactly the same as we talked about yesterday about slicing. So any questions so far for the slicing? Okay, I didn't see any questions here, so let's move on. Let's continue. Oops, just one second. Okay, so here we just we'll talk about a little bit about the multi-dimensional array and the slicing for multi-dimensional array, since we don't talk about it previously. So let's first define a multi-dimensional array. So the definition will be very similar as the 1D array, right? We put those elements in square brackets, and we use a comma to separate 2 different rows, and we can define the data type here. And if we print it, we can see we get a 2x4 array, right? Exactly the same as what we defined with 2 rows, and each row has 4 elements here. And we can also use shape and size for multi-dimensional array, right? So here you can see for 1D array, you will return a tuple with 1 element. Here returns a tuple for 2 elements, right? Which means it has 2 rows and 4 columns. And A dot size will return the number of the total number of elements in this array, which is 8. Right? 2 by 4 is 8. So so let's print the dimension of it. So the dimension is 2. So because it's a 2D array, right? So it's a 2D array, so it will return the dimension as 2. So see something. So 3D array, well, for 3D array, there's a specific way of writing a 3D array, or you can use basically initialize a 3D array by using zeros or ones. Right? So for 3D array, the shape will be if you print the shape, will be 3 numbers instead of 2 numbers. And is there any difference between A13 and A1? Well, I'm not sure, like, what do you mean by these two different formats? If you mean by array definition, I'm not sure by array definition, or you mean the indexing of the array. If it's the indexing of the array, then there's no such kind of ways for A13. I'll show you later about the how do we do the fancy indexing. Yeah, I mean, yeah, I'll show you how to do the fancy indexing later. We will talk about it. And okay, let's see A1. So here, let me check. Okay, no more. So here, like, you can also use indexing for index for the multi-dimensional array. So here, if you specify 1, right, what will print? You won't print the first element. You will print the first row, right? Not the first or the second row. So index 1 means the second index. So it will print the second row, right? So here, A13. So what does it mean? So it means we can use both index for rows and for columns. So first number means the index for rows, and the second number means the index for column. Right? So let's see, A13, we have 13. So which means we want the element from the second row, the fourth column. So let's see, the second row is the second row, and the fourth column is the last column. So we get 13 here, right? And the same thing as 1D array, then we can change the value of it. Right? We will print it. 13 will be changed to -1, right? And here we create an array, and we can also use slicing, right? We can use slicing for 2D array, and we can use 2 sets of slicing for both rows and columns. Right? Here you can see we have A0, and 3 to 5. So the first number means the number of rows, which means we want the first row, right? And then 3 to 5 means we want the element, we want the element from the 4th to the 6th row, right? So which means we have the first row, and the 4th column is this one, and the 6th, we only have 5 columns, so the result will be 4 and 5. Right? Only elements 4 and 5 meet the requirements. Right? Here the same thing, right? Here the same thing, and the column is a little bit different from the 4th one to 5th one. The 5th one will not be included, so it will only print element in the first row and 4th column, so which is 4. Right? And here, same thing. Same thing for the 2 slicing, right? We want the elements from the 5th column and the 5th row till the end. So we only get one number, which is 25, right here. And from the fourth row and fourth column, like you can see we get four numbers, 19, 20, 24, 25 here, right here. Right? Slicing is like pretty much the same. So this example, you can see we want to get, for rows, we want to get all the rows, right? Because we didn't specify the start and stop for slicing rows. And for columns, we want third column. So it will only print the third column here. And then last example, pretty much the same, right? Except we add the step in there. So the step will be involved. Right? We'll get something like this. Right? I think pretty straightforward, just that the difference of 2D element, the slicing for 2D, slicing and indexing for 2D is basically, we specify two sets of them for both rows and columns. So if you think them separately, then they will be very easy to understand, right? Just two sets instead of one set. So any questions? Okay, let me see. 4 is to them. Let me see which one is that. The 4. Okay. Let's take a look. I think that's because 3 is two-dimensional. I think it will be the same as the format of the slicing, I believe. So because 5th to the end and 4 to the end. Yeah, I think the format will be the same. So the 4 I think it treated as a 2D array because it's from the 5th to the end, the 4th to the end. Well, if you you can see the 3 it also returns a 2D array because it's from the 4th to the end. Well, if you like say if you have something, you can see 0 and 3, 5, right? So this is for rows. For rows, it only specify one number, so it will return only one, like only 1D array. Well, for this 4 to the end, from the 5th to the end, and 5th to the end, it will return a 2D array because it specifies a 2D array here. And here the same for the last example, you can see it also returns a 2D array here. Yeah, both dimensions are being sliced. Yes, correct. All right, so let's see. Okay, let me see more questions. So let's move on. Let's talk about. Just one more thing. Okay, I forgot to mention just one more thing. So first for slices, if you change the value of the size, the original array will be changed. So here is the example. Okay. So we first define array A, and we define B as the slice of A. Right? And then we change one of the elements of B to 7, and then we print A again. You can see A has been changed. Right? So just be careful if you change the value of a slicing, then the original array will be changed. Okay, this is just one more thing I want to mention. Nothing else, then okay, let's talk about masking. Okay, so um, NumPy allows the use of Boolean values, right, for the elements of for the element of arrays. So basically, we can use that to mask those elements that we don't want. Okay, so and NumPy allows the array of for those arrays that has Boolean valued as the how to say that. So NumPy allows the arrays that has Boolean values as the index of another array, right? So let's check those examples. Let's check those examples first. Okay. So first we define a 1D array, and then second we define a mask. So we define an array mask. So you can see the expression here. So mp.abs a minus 5 larger than 2, which means a minus 5, which means we want the absolute value of each element of a minus 5. Right? So if it's larger than 2, then it will return 2. If it's not larger than 2, it will return false. So if we print the mask here, right? So you can see mask is basically an array with Boolean values instead of numbers. Right? You can see true, false, false, true right here, right? So, and we can use this mask. We can use this mask array as our index for another array. For example, we will use it for A. Okay, so here you can see we print a mask, right? Use the mask array as the index of A. So what we will print? We'll print something like this. So why will print like this? So it will filter those arrays that we don't want and will show the arrays based on the Boolean values of the mask array. So you can see the first 3 elements of the mask array is true, and the last 2 elements of the mask array are false. So it will only show the first 3 elements of A and the last 2 elements of A. So because the Boolean values in the mask, they're true, only these elements are true. So you'll print the corresponding elements in A. So you can see the first 3 elements 0, 1, 2, and the last 2 elements 8 and 9, right? So we can also create a mask by ourselves manually, right? Instead of using expression like this. So here you can see we create a mask 0, 1, 0, 1, 0, 1. So 0 means false, 1 means true. So let's print the mask, right? You can see false, true, false, true, false, right? And then we apply this mask to B. So B is basically the result we have. So you'll print the second and the 4th element, which is 1 and 8. Okay? Very straightforward. And you don't forget to, if you want to create a mask, don't forget to change the D type to Boolean. So any questions for the mask here? No questions? Okay, yeah, I think they're pretty straightforward. So let's talk about 2D masking. Okay, so 2D masking is basically the same as 1D masking, right? Just very similar to like slicing or indexing. We have two sets of masking for okay, no, nothing in chat. So we have 2 sets of masks, right? For rows and columns, right? Or we can just apply mask for just only columns or only rows, right? So Oops. So I got one question there. You apply the mask to the array, but still keep the size and shape of the array. But why you want to do that? The, because using mask, we basically what we want is to mask out the specific values. Yeah, that's what we did. Right? We use a mask array to basically filter those arrays, right? To filter those elements that we don't want. Okay? I mean, like if you mask out those arrays, the result you get won't have the same size, right? Think about it. Like if it's like for example, it's a 1D array, right? You can see we have 10 elements here, right? If we mask some of them, the size may not be the same. Right? The if you print it here. I have to run from the top. Right, you can see the mask is definitely different from I'm not sure what, like what you're asking, like keep the size, like for the first question, I'm still talking about the first question, like why you want to keep the size and shape of the array. Right? If you filtered some of the elements, then you will be definitely different, right? So if you want to keep it, or say maybe you're thinking about like change them to 0 or something. Then you can basically, you can basically change them to 0. So by using indexing, right? If you want to change them to 0 and you know the index, then you can change them to 0 if you know the index.
Yeah, I think if you want to keep the shape of the original array, then you need to use the indexing in this instead of using the mask.
Yeah, if you like the mask just like basically filter.
Yeah, mask will select a certain number, so the shape will be changed. But if you use the index, still those the shape of the array or the matrix will be kept.
Yeah. Right. Okay. So let's move on. Let's talk about the 2D mask. The 2D mask is basically, like I said, it's basically the same as similar to the 1D masking. We just have two sets of masks, right, for rows and columns right here. So, one thing, you can use the mask elements on the left-hand side of the assignment. I'm not sure, like which part you're talking about. I'm sorry. Would you please repeat it? Like, you mean the result? Okay, phone has answered this question.
You can try. I think what the user is asking for is that you want to use the A mask and to the left side of the expression.
Yeah, I think you can. So
yeah, you can probably you can open another cell and show it.
So we can we change it here? Like,
Yeah.
yeah, the same result you can see. Right? Just simple, we change it. We change the B to the right hand side, and it also worked. So yeah, let's see the example of 2D masking. So we create a array like this, okay? And then we manually create a mask. Okay? So if we use like a mask directly, like 1D arrays for 2D arrays, it will apply the mask to the rows. Okay, so you can see we have 0, 1, 1, 0, 1, which means we want to mask the first and the fourth index. Right? So here, if we apply the mask to the rows, which means we will mask the first and the fourth row, right? The first and the fourth row. So we will get 3 rows, start with 15, 20, and 30. Right? So you can see the result here. And here, same thing as slicing. So for rows, we want all of the rows. Right? We won't mask anything. And for columns, we apply the mask. So it will filter the first column and the fourth column, and will return columns start with 11, 12, and 14. So here, straightforward and similar to the 1D masking. So any questions here? Wait, there's something.
Yeah, I think what the audience is asking for is if you use the mask to assign value of certain element. I give an example, like you have an A equals actually, let's first forget about the two-dimensional case. Look at just one-dimensional.
Mm-hmm.
You have an A equal numpy 1, 2, 3, and you use the mask to mask the first one. And then you can use the mask to assign values to those specific elements. In this example, I just mask so that the number 2 and number 3, the second and third elements are kept, and you can use the mask to assign a new value to them, and there's no problem.
Okay. Yeah. Okay. I think Fong answered the questions. So, okay. Any more questions? Any more questions? Okay, no questions. So let's move on. Then we will talk about next. We will talk about fuzzy indexing or advanced indexing. So for masking, we just we use Boolean values to use Boolean values in arrays. So here we can also use integer values in arrays for indexing. Right? So here, let's see the first example for 1D array. First, we create a 1D array, and then we create another array I contains element 1, 3, 5, 1, and then we use array I as an index of A. So it will return the elements with the index same as the element in I. So you can see basically the first result is A, and then so for I array, the first element is 1. So the first element of the result will be the second element in A, which is 1, and the second result will be the fourth element in A, right, which is 9, because 9 has an index of 3, right? 9 is the fourth element. And the third element will be the element in A that has index of 5, which is the sixth element, right? Which is 25. And we can print the second element again. So we get a result 1, 9, 25, 1, 1. So, and for 2D indexing, like we talk about like 2D slicing, 2D masking. So for 2D indexing, it's very similar, right? It's very similar. So like I think you already know, like it's the same as like slicing or masking. There are two sets of index, right? So here you can see we define a B array, and we have two arrays for indexing I and J. So we use I for indexing of rows, and we use J for indexing of columns right here. And you can see this is the result of B. And what is the first element of the result Bij? So first element will be the index 0 in rows and index 0 in columns, which means the element at the first column and the first row, which is the very first element, which is 0 here. And for the second element will be the index with 2 in row and index with 2 in column, which is the third row and the third column, right? We can see 100, element 100 is and then the last one with the second row and the fourth column. So the second row, the fourth column, which is 49. So we get 0, 100, and 49. Okay? And so here we can have the, so for example, here another example. We can have like 2D arrays for indexing as an index array. So here, so how do we use this one, right? So you can see they're basically index for 2 rows, right? The results will be the same shape as the index array. So if your index array is like 1D array, the results will be 1D. And if your index arrays are 2D arrays, and the results will be 2D. So here you can see we specified index for 2 rows. So let's go from the first row. Right, for first row, we have 0, 0, 2, 3, right? 0, 0 is basically 0. 2, 3 is basically 100. So 2, 3, the second row, I'm sorry, 2, 3 is basically 121 here. Right? So the first row of the results will be 0, 121. And then for the second row, we have 2, 3, and 1, 1. 2, 3 is the third row, the fourth column, and we have 121 and 1, 1. 1, 1 is the second row, the second column, and we have 25. So here is 121 and 25. Okay. So just 2 simple examples. Any questions? Any questions for advanced indexing? Okay, so I didn't see any questions. Okay, I didn't see any questions. So, let's take a look at an example of using masking. Okay, masking and plotting. Okay, so I think we talked about a little bit of masking plotting yesterday. Okay, so using matplotlib, so it's just very straightforward. Let's take a look at this example. So first, we use link space to create x and y, and basically y is basically the sine function, right? And we use matplotlib to plot this function. Right? You can see we plotted in blue color and square legends here, right? And then here we create a mask, right? We want all the values larger than 0. And we apply the mask to both x and y here. And then we plot the results. Right, we plot both the results of original x and y and x and y after masking. Right, you can see we plot the result after masking in red color, and I think not very clear, just red color and square legend here, you can see we get only the result with positive numbers larger than 0. Okay? And we create another mask with y smaller than 0, x larger than half of the negative pi, right? And then we print this result. You can see in the purple or magenta color here. Blue is the original curve for sine function, and then the magenta color you can see this is the result we get in triangle legend. I think just this is an example of visualization of masking, so you can see more clearly on the plots, like which part has been filled and which part has been cut. So any questions for this masking and plotting? Okay. No questions. I didn't see any questions. So okay. So let's go to the next session. I think that's the last session, pretty much the last session of the morning workshop. So for the last part, we will show you 3 examples of using them. Okay. So so the first example is how we calculate the derivative of function. So here we basically use Euler's method. It's a numerical method. So I'm not sure if how many of you guys have. I think most of you guys are familiar with this method. So we first define x and y. Here are the same, the sine function, and then here we define dx and dy. So do you guys understand this part, like dx and dy? So let's see what is dy. So for the first term, we basically use a slicing, and we want to get the element of y from the second to the end. Right? The second term is we want to get the elements of y from the first to the last one, but the last one is not included. So what is dy? So the array dy basically returns an array with elements. Well, the first one is the second element of y minus the first element of y, right? And the second element of dy is the third element of y minus the second element of y, right? And so on. So which creates dy, right? If you know how it works, it's very straightforward. And same thing for dx. Oh, this one first. Okay. And then we plot the result. Right. You can see the blue line here, the no legend. Right? The line has no legend here. Prints the original x and y, which is the sine function. Right? And then which is the sine function we created. And then we plot the derivative of the results we get in red cross. Right? Here you can see the red cross. And then, you know, like the derivative of sine function is cosine, right? And then we plot cosine here in a green line. So you can see they're basically overlap. Right? So any questions for this example? For the first example, derivatives. I think this very straightforward. Okay, let's move on to the second one. So second question, second example, we want to change our RGB. The secondary axis, the second line on secondary axis. Well, I think there's an option in Matplotlib. I'm not sure second axis. If you want to plot, like say 2 lines in different plots, but in the same page, right? We will talk about it. You can use a subplot. I'm not sure I've never used like if you mean you have two sets of axes in there. If you mean if you have two sets of axes here, I'm not sure how to use it because I've never used Matplotlib for these type of plots for two axes. But if you want to say put two plots at the same row or same column, you can use subplots. Yeah, if that's the case, then you can use. We will show you like the subplots there in the next example. But if you mean you plot two lines in the same plots, but you have two sets of axes, two sets of values of axes, then probably you should go and check the Matplotlib documentation. I'm not sure at this moment. Yeah, you mean I'm not sure at this moment. You have to probably set the two sets of axes first, and you should have two sets of values, I think. But I'm not sure how Matplotlib will handle this type of plots at this moment. Yeah, I've never tried this type of plots in Matplotlib. So maybe we can figure out in the afternoon hands-on sessions. Like we will spend some time figure it out. But I have no idea for now. So yeah, we can definitely do it in the afternoon session. Yeah, there are a lot of options. Yeah, tick marks. I mean, there are a lot of options. Oops. Yeah, there are a lot of options. But if you go to the, I'm not able to cover like all of them. Like the legends, like here you can see, just this example, like XR here means we plot in X marks, cross marks, and in red color. And you can see some similar things in the previous plots. So a lot of options for Matplotlib. I cannot like talk about all of them. So if you go to the documentation of Matplotlib, there's a list of all the options that you can use. Okay, so and just choose whatever you want, whatever you like. Okay, so next we will talk about change the RGB image to grayscale. So here you can see first we need to have a image file. So here we do the same thing. We check if the image file exists. If it does not, we'll download the file from the link, right? Like we did previously. And then we use another Python module called image.io. So image.io is basically a Python library that provides an easy way to read and write image data. And all of the image data that has been read will be returned as a NumPy array. Okay, so let's run this. Right, you can first we define the name of the file, and then we read those files. Use image.io.imageRead, right? And we print the result. You can see it's a NumPy array. It's basically a NumPy array, and we then print the shape of the image. Here you can see you get 400, 248, and 3, right? So which means this image has a height of 400 pixels. And a width of 248 pixels and 3 color channels, which is RGB, right? So let me see. RGB, so which is RGB 3 in color channels here. So and then there's several ways like we can do to several ways we can use to convert a RGB image to a like grayscale. So here what we use is a weighted average. So we add a specific weight to the RGB channels, and then we turn it to we do the average, and what will happen, right? It will be the shape will be changed. Right? will be a two-dimensional array. So here we do the average along axis 2, right? Axis 2 is the third direction. It's the third channel, which is 3, right? So after we do the average, it will become a 2D array. Right here, and then we plot the two different image. The first one is the original image here, and the second one is the one that we turn it to grayscale. So you can see if you want to print these two images at the same time, then you can use subplot. Right? Subplot using here, and then so here's a note like so we first change it to unit 8 before displaying it, and then it's you can see the left one is the original RGB, and the second one is the grayscale. Right here. Okay, so let's see the questions. I think you will need to check the image IO. I think multiple format, a lot of format that image IO support. Like a lot of I didn't see when I was checking the documentation, I didn't see a specific list, but a lot of, like here we use a JPG file or JPEG file. I think they also worked, and like GIF files, like a lot of them. Right? I think they may have the list on the image IO documentation on their website, and you can check it. I think, as far as I know, I think JPG, JPEG, GIF, they all work. And the subplot is like what we talk about. If you want to plot the two figures in the same page, okay? So you can use the subplot. So basically, it shows the position of the plot right here. And for the last example, we will talk about how to calculate linear regression. Okay, so here we will use we will talk a little bit about SciPy. Just use one function from SciPy. So here you can see from SciPy we imported stats. Stats is basically a module contains a lot of statistical functions from SciPy. So here you can see we have two arrays, X and Y, and we want to get the linear regression of it. So we use the stats dot linear regression, ling regress of X and Y, and then we plot it. The original data point are plotted in red dots here, and then the result of the regression we plotted in blue line. Basically, right, the line will be x times slope plus intercept right here. I think very straightforward for using SciPy. I think NumPy plus SciPy. So 3 examples. I think that's all for this morning's session, and we will talk about we will have a hands-on session this afternoon starting from 1 p.m. I think. So let's see, there is an exercise. I'll show you how to get the exercise. If you go to GitHub page in day 2, on the day 2 folder, there is a file named numpy warm-up exercise.ipynb. So you can also open this one in Colab. You can also open this one in Colab, and then you can see there are a few instructions of few questions asking you to do it okay, to finish the questions. Okay. Right. So just probably if you want to do the exercises, spend some time in the afternoon sessions, and in the afternoon we will have the same as yesterday. We will have breakout rooms, and if you have any questions, you can ask, and we will answer the questions, and we will talk about the exercise at 3:30. The same as yesterday. I'm not sure. Like we will. Okay, let me